Okay, good morning, everyone.
Hi, sweetheart.
I think I need to mute here. Okay. Before I take all your questions, so if you guys have questions, start putting them on chat. Any questions about the homework? I like to make one comment about the quiz. That's the only thing that stood out, is in the formula for the arc length. Okay, so in the picture below, find the length of the arc that's cut off by each angle. And the length of an arc, the formula is S equal R theta holds when theta is in radian. It means when you use this formula, the angle theta is in radian, not in degrees. So some students use the formula. So, no, sorry, that's not this problem. My apology. Right there, number 3, that's where the problem came up. So I gave you the arc length and I gave you the radius, and you have to find theta. So a lot of students remembered S equal R theta, and they solved for theta. Theta is 4. This theta is the unit you get when you use this formula is radian, not degree. Maybe if you look at the picture, 4 degrees is really, really very tiny. That's really 4 degrees. So this there is no way it could be 4 degrees. That's one thing that will indicate for you that the unit is wrong. But the formula hold only tells me if the angle is in radian. It means when you use it, whatever you get here, that's in radian. Because radian have a geometrical meaning. Radian is by definition. By definition, a radian means you take a length, 1, and that's the radian. So that's the relationship between the arc length and the radian. So when you take a radius of a circle of radius 2, if this is 1 radian, this of circle 2, this will be stretched, and this will become a length of 2. Okay, so that's really the main mistake. Some students put 4 degrees. The formula hold only in radian. So that's really the main comment about the quiz. Otherwise, you guys did very well. So now I go back to your question. Any questions from the homework I've assigned? Anybody? Okay. All right, so when you don't ask question, I assume you were able to do it, and I insist that you do it because that's the only way to learn. So let me recall a little bit and ask you a few questions about it, and then we proceed to the following problem. Please put your camera on. It makes teaching much easier. Okay, please do that. So let us recall what we did last time. Okay, so recall the basic fact. We did the graph of the sine and the graph of the cosine. And as I said, I want those to be, even though you can look them up, but I want you to memorize them because they are so crucial for anyone who wants to do, who needs math, and that's crucial. The sine always start at the origin, it goes up, come back here. The period is 2 pi. It means that after that, it starts repeating itself. This is the pi. It's nice to know all those. It peaks at pi over 2, and the lowest value is at 3 pi over 2. That's a 1, and that's a minus 1. So that's the sine of t. The cosine starts at its max. That's really the cosine. And it goes down, up, back up, and then it repeats itself. The period is always 2 pi. That's my 2 pi. It reaches its lowest value at pi, which is a minus 1. It reaches its highest value at 0. And those two, it means it intersects the horizontal axes at pi over 2 and 3 pi over 2. So these are the main two graphs. Okay, so, and then we said that we can take a graph and we can stretch it vertically. We did that. And we can stretch and lift. And then we create a whole new function. And then we said the form of those functions will be, the general form will be something of the form A equals sine t plus k. or A equal A cosine t plus k. And those are function. If we graph them, you will have a graph that looks like sine or cosine. In this one, the amplitude, so we'll get a periodic function, is the absolute value of A. And what else? The midline, y equal to k. And the period haven't changed yet. It's 2 pi. Okay. And if A positive, we get exactly like the sine or exactly like the cosine. If A is negative, it means we flip the sine or we flip the cosine. That's really the idea that we did last time. So I'm going to ask you a few questions related to that before we move on. Okay, so a basically problem from the book itself. So let's start. Suppose I take y equal, simplest one, 2 sine t plus 3. Okay, I want you always to understand this. This stretches the graph vertically, and this shifts it up vertically. That's how you should understand it. You don't really have to memorize it, but that's you have to understand it. So I want everything. I want the amplitude. I want the midline. The period, right now, the period is not an important play. It's always 2 pi. That's what we're going to change today. And then a quick graph. So very quickly, I want the answer. And let me pick one of you. As I said, I pick you, and then I forget that I picked. So don't worry. Samantha, are you with me? Are you with me? Yes, no. Okay, I move on. Rebecca Zeman, are you with me? Rebecca. Oh, sorry, Rebecca is right with me on chat. So the amplitude is 2. The midline is y equal to 3. The period is like the period of the sine. It's 2 pi. Nothing is really changing. So suppose I want to ask you to graph this. Okay, graph this function, because we should have an idea how to graph it. Graphing is actually not hard because we know that it looks like the sine. Okay, we know that. We know the midline is y equal to 3. So that's the midline right here. Now the sine, we should always know it starts at 0 and it goes up. That's really the graph of sine. This is take the graph of sine, so it looks almost the same. It's going to stretch it by 2 and shift it. So it's going to start right here at 3. It's going to stretch it by 2. So we're going to peak, we're going to go up 2 units. Then we're going to go down 2 units from 3 and back up. So that's how it's going to look like. So we're going to start at 3. That's positive, so it looks like sine. But this time, from here to here, it's 2. That's where the amplitude is playing a role. And from here to here, also, that's the 2. That's the amplitude. And this is 2 pi. So that's how we graph, just the sine shifting it up. So a very simple question, because these are, actually, I want you to do those. This is here is 2 pi. All right, what's the value here? Quickly, I want answers. This red here, this dot, it means this function is going to peak for which value of t? Anybody? Remember the sine? That's exactly the sine. The only thing you did with it is stretch it and shift it up. So it's going to peak like the sine so far at pi over 2. What is the value here? I want somebody else. All right, the value. It means where it's taking its minimum value. Remember, always imagine the sine that you're working with. Where is the minimum value obtained? No, not pi, not pi. It's 3 pi over 2. And you're right, the minimum value is 1, that's correct. It's obtained when t equals 3 pi over 2. And what's this value? When it intersects the midline for the sine, what this should be? So the sine peak at pi over 2, 3 pi over 2, that's the top, that's the valley if you want to think about it. And then it intersects the midline at pi. Okay, so 2 pi is divided into 4 pieces. Pi over 2, that's the peak, pi, 3 pi over 2. And that's really the graph. So it's not hard to sketch the graph of those functions once you start with the sine. So now I'm going to take another 2 problems. It's from the book. So this is, I think that's 1 from your book. And that's number 2. Oh, no, 3, I guess. 3. Y is 3 sine t over 20. Over 20. So again, I want everything, the amplitude and the midline and the period, which is, as I said, so far is 2 pi. It means the graph repeats itself on every interval of length 2 pi. Okay, what's the amplitude? Okay, 3 over 20, absolutely. The first thing is to rewrite it. I mean, it's crucial. Times the sine of t. So it means, is this a new function stretching the graph or shrinking, compressing the graph vertically? What can you say? Is it stretching the graph or compressing the graph? So the amplitude is 3 over 20. The midline is 0 because I'm not shifting. There is a 0 in here. Right, now the period is always 2 pi. But what's the effect? 3 over 20 is way, way less than 1. So now what we're doing is the graph of sine, we're actually compressing it because the graph of sine go up to 1 and go down. That's the sine. 3 over 20, this is a number which is less than 1. So what we're doing, it's actually shrinking, compressing it by 3 over 20. So my graph is going to look like that. It's like the graph of sine, but it peaks very, very low. It peaks very, very, very low, and the valley is very low. I mean, it means this is the 3 over 20 right here. Right here is the minus 3 over 20. So it's actually compressing. It's really compressing the graph. Okay. Right, so two more, and then I move on to the next section. Suppose y number 4. Okay, y equal 5 minus 2 sine t over 4. Sorry, over 5. Okay, and now the question is again, I want every aspect of it. I want the amplitude, I want the midline, and I want the period. And please, I want everybody to answer the question. Please, all of you. I'm calling on some of you, but they're not answering, so I'm moving on, but please get back with me. Okay, I'll give you a minute to see what you guys have done. And I'm giving you a hint as well. So you have to rewrite it into format, which is a sine. You have to rewrite it into this format so you can read everything. So that's the format I'm after. A sine t plus k, or a cosine t plus k. Once you add in this format, we can visualize what's doing. Amplitude, okay, anybody else? Sorry. Anybody else? Okay. No, no. We're getting better. First, we're gonna rewrite it. How are we gonna rewrite it? Okay, 5 belongs to everything. So we're gonna rewrite it. It's gonna be 5 over 5, be careful, minus 2 sine t over 5. So we have to divide across the board. That's what it means to divide by 5, which is going to give me 1 minus 2/5 sine of t. So we have to rewrite it this way to be able really to figure out everything. And now we're fine. The amplitude is positive. The amplitude is the distance between the midline and the maximum value. So the amplitude here is going to be the 2/5, so it's positive. Okay, and then the midline is going to be the line y equal to 1, and the period, as I say, is not changing, is equal to 2 pi. Okay, so if it's given this way, we have to rewrite it into a more familiar way. And now if you want to sketch this graph, okay, I will sketch it because I want you to know exactly how things looks like. So we sketch it. Okay, now see how I sketch it. It looks like sine, but since there is a minus, it's the sign. So this is my sign. It's going to be upside down sign. This is 2/5. It means this sign is we're going to shrink it by a little bit. 1 is going to lift it up by 1 unit. So we know that I was usually start by the midline. So that's y equal to 1. And then it's look like a sign with a negative. It means the sign start at the midline, but we're going to go down 2/5. We're going to go up and then back here. And this is my 2 pi. My amplitude is from here to here. That's 2/5. That's the distance. From here to here, that's my amplitude. And that's really how my graph is going to look like. Okay. All right, so my last question is the following. Again, I would like, does the period, no, we're changing it today. The period, as long as it's sine t, it is 2 pi. And today we're going to start changing the period. And we're going to do what should we do to have any kind of period we want. So it's 2 pi as long as sine of t. It means there is a t in here. Okay, and then we're going to change that today. That will be the goal today. All right, but once we are strong in those, so the last question I'm going to ask is again from your book, and they're giving you a graph, and your question is to find the equation that will fit it. So I assigned 2 problems. I'm going to pick one of them, and you guys should have done the other one. So that's the graph. Okay, and that's problem number 27 in your book. And I'll try to graph it as, so the graph from the book look like this. And this is 2 pi. And then it's repeating itself. So that's, sorry, it repeats itself exactly. So it's gonna go down by the same. So those values aren't changing. It's just repeating. And then it goes up and then it keeps going like that. So this should be the 4 pi. And that's really a cycle, okay? And the number they gave us, the numbers are 5 from the top, and down here, it's a -1. And the question is, find a formula of the form a cosine t plus k or a sine t. All right, so what did you guys come up with, and how did you handle this problem? What do we start by drawing? What do we, if I am you, I mean, we did that last time. What do you think is the first thing to draw? To do, to figure out? What would you figure out? Okay, Phoenix, you're with me? Phoenix, are you with me? Yes, so can you talk? Is it sine or cosine? Yes, okay, then talk. What would you like to, everything, Asia, you're right. So what would you like to figure out? What would you draw first?
First you'd probably draw the cosine and sine graphs, right? To see which one it is.
Yeah, and then?
And then you want to figure out the amplitude in the midline.
Yeah, so I'm going to start with the midline because midline usually give me an idea. Why midline helps me? Because if the graph start at the midline, it's a sine. It doesn't start at the midline, it's the cosine. And that's really what I like to do the midline. And then I do exactly what you said. So what's the midline here? What's the amplitude?
The midline is 2 and the amplitude is 3.
Very good. Why? How did you get the midline? Did you figure it out or you used a formula?
I just looked at the picture.
You look at the picture, which is what I like, but I will use both. So from here to here, 5 and 1, so we have 6 units. Half of them is 3 units. So I have to go down by 3 or go up by 3. It means that's really my amplitude is 3. From here to here, it's 3. So this is, as she said, you looked at it, it's halfway through y equal to 2. Okay, and believe me, I usually look at it. I usually don't use formulas. I look at it, and that's going to be equal to. Now, if you guys want to use formula, which is okay with me, the formula for the midline is you take the maximum value and you add the minimum value of the function and you divide by 2. Believe me, I usually forget it because I don't use it. The maximum value is 5. The minimum is 1 divided by 2. 4 over 2, this gives me the midline. And the amplitude is exactly, you see how far those are from each other. So you take the max minus the mean divided by 2. The max is 5 minus minus divided by 2, which is going to give me equal to 3. That's the amplitude. Okay, so now we have everything. Now, once you draw the graph, now you ask yourself, is it a sine or a cosine quickly? Phoenix, since you're working with me. Phoenix or Asia, anyway. It looks like, finish the sentence, absolutely a cosine. So now, and the period in this particular problem is always 2 pi. It's always 2 pi. So it's basically the graph of cosine, okay, stretched by a factor of 3, and then shifted up by 2. So the graph would be 3 is by how much we shifted, cosine t plus 2. Okay. So this is the formula for this particular function. Right. Okay. So let us see what we did so far. Let's look at this formula. Multiplying the cosine t by 3, it means multiplying the output of the cosine by 3. What the effect of it is to stretch it vertically. Okay, so this has effect, vertical effect. It's just take the graph of cosine and stretch it, basically. And adding 2, so that's stretch, or sometimes compress. It compresses if the amplitude is less than 1. So this one stretch vertically, that's what we study. And this 2 basically shift vertically, up and down. Shift, up and down. Okay, that's really the effect. What we're going to do today is actually, we're going, instead of stretching vertically, we're also going to take the graph of the sine or the cosine and actually stretch it or compress it horizontally. So what we're going to do today is, on the top of the vertical, we're going to do stretch or compress, you don't have to write this, horizontally. It means I want to change the period. So basically, I want to take the graph of cosine and replicate it, but on a smaller period, something like that. Compress it a little bit. Or we want to like stretch it a little bit and make the period different. Okay, so the idea is that what is in the formula that will allow me to be able to create a new function where the period is different. So what I'm going to do now is basically change the period. Okay. So before we do that, let me make sure so section 7.5, that's what we're going to start now. It's called sinusoidal function. So sinusoidal mean function that look like sine and cosine. Okay, but first let me make sure we understand the difference between those two. Suppose I give you y equal 2 times the sine of t versus y equal the sine of 2t. Okay, first let's make sure that we understand that those are very, very different functions. So in here, I'm multiplying the sine by 2. So for example, if I take t equal to 4, no, sorry, no. I want to take a nice number. So suppose I take t equal, let us say, pi over 4. Then this y will be 2. You multiply 2 by the sine of pi over 4. Now the sine of pi over 4, we know it. It's the square root of 2 over 2. So here you're multiplying the sine by 2. That's why the effect is vertical. When I take this function, what are you multiplying by 2? Back to you. What do you multiply by 2 here? What you multiply by 2 is the t itself. So this is a very, very different function. This is the sine. So I'm not touching the sine. I'm not doing anything vertical. But the inside, I'm multiplying it by pi over 4. So which is going to give me the sine of pi over 2. So this function takes at pi over 4 the value of sine at pi over 2, which is equal to 1. So I don't want you to confuse those two types of functions. Here, we're multiplying the sine by 2. And this is we're multiplying the inside by 2. So those are very, very different. So I cannot pull the 2 out. Those are very different functions. Now, the idea is that what's the effect? When you multiply the inside by 2, what's this will be the effect on the graph? Okay, so to do that, we're going to just graph them. I'm going to share the screen with you, and I'm going to graph them with you. And I'm going to ask you questions. What do you notice? What's really going on when I multiply the inside by 2t? Okay, this will be my question. All right, so we're going to graph y equal sine t and y equal sine 2t. Okay, and I'm going to graph them. I'm going to share the screen with you because you guys will be able to see it better. And I'm going to sketch both graph, and I'm going to ask you, what do you really notice is going on? So let me share the screen. Let me find the one I want. Oh, sorry. Share the screen. Okay. Right, and all right. So let me see, how can I make this long? All right, I have to move this a little bit. Okay. So this is the graph of sine x. Okay. So this is the graph of sine x. It starts at the midpoint, at the midline. It goes up, it hit 1, peak at pi over 2, pi, and then all the way to 2 pi. Okay. Now what I'm going to do, I'm trying to see how can I get rid of, trying to move this down here. Okay. So this is my graph, okay, up to 2 pi. Now I'm going to take the graph of sine 2x. Now I have to put x instead of t because as you go, your calculator does not accept the t. Now this is the graph of sine 2t. Okay, so I multiplied the inside by 2. What can you say about the graph of the new function? Red is the sine of x. The blue is the sine of 2x. What is the effect on it? What's really going on? Please speak up. What's being affected? Anybody? Don't chat because I don't see chat, just speak. I don't see chat for a second because I'm sharing.
The period is being affected.
The period is being affected. Let's watch very carefully. Between 0 and 2 pi, the graph of sine 2x, how many times is repeating itself? One time? Two times. So multiplying by the sine 2x, its effect is that my new graph, which is the blue one, looks like sine, really looks like sine, but the period now is half because, as you realize, we have the graph repeats itself 2 times within an interval of 2 pi. In my case, the amplitude hasn't touched. I did not touch the amplitude. The amplitude is always 1. What's really changing is actually my period now, which is going to be equal to pi. All right. Let's see what's going to be the pattern. I'm going to, instead of sine 2x, I'm going to graph sine 3x. So I'm multiplying x by 3. And now I want you to tell me what's really now going on. What's going to be the period here? Again, amplitude hasn't changed. I did not multiply the outside by anything. I multiplied the inside by 3. What's happening to the period now? What do you think is going on? But who can guess the period? Please speak up because I can't see chat now. So from the red one has period 2 pi. Means from here to here, we have 2 pi. How many times is the green graph repeating itself in the interval of 0 to pi? I need answers, please. Answers.
3 times.
3 times.
3.
Okay, 3, right? 1 up to here, then another one up to here, and then a third one up to here. So what do you think is going to be the period of the green graph? Can anybody give it a good guess? So from 0 to 2 pi, the graph repeats itself 3 times. What do you think is going to be the period? It means how much we have from here to here. How much we have from here?
Over 3.
2 pi over 3, absolutely correct. Because from 0 to 2 pi, the graph repeats itself 3 times. It means each one is 2 pi over 3. From here to here, 2 pi over 3. From here to here to 2 pi over 3. So let us watch the pattern. So what's happening is the 2 pi multiplying by 3x turn the 2 pi. So what if I plug in 2 pi in 3 sine over x, the value at 2 pi is going to be shrinked all the way to 2 pi over 3. All right, let me do one more graph and see if we can watch the pattern. So I'm going to get rid of that, and I'm going to take sine of 4x. I'm multiplying the inside by 4. And then I'm going to ask the exact same question. It looks too much going up and down, but let us analyze it. How many times does my blue graph repeat in the interval between 0 and 2 pi? So the graph go up, down, that's one cycle, then another cycle, a third cycle, and a fourth cycle. So how many times is the graph repeating itself quickly?
4 times.
What do you think? I want all of you. What do you think the period is going to? Within 2 pi, it's repeating itself 4 times, exactly 4 times. So what's going to be the period? It means from here to here.
Pi over 2.
I mean, it looks pi over 2, but where did we get the pi over 2? If I didn't have pi over 2 here.
It's 2 pi over 4.
It's
and then
2
you would
pi,
just
exactly. It's
simplify.
2 pi divided by 4. It's 2 pi divided by 4 because the graph is repeating itself 4 times. Okay, so that's really graphically what's really going on. So if I close this, go back to sine 3x, the period was 2 pi over 3, which is what x is multiplied by. If I went back to sine 2x, the period is basically 2 pi over 2, because that's how many times the graph is repeating itself in an interval 0 to pi. So that's really the effect of multiplying the x. multiplying the input by a constant has a horizontal effect on the graph. It either stretch it or compress it horizontally. So multiplying the inside will have a total horizontal effect on the graph. So let us come up with the formula. So I'm going to stop sharing with you guys and now I come back. Okay, so now what's really the effect on the graph? So graph of y equals sine t versus the graph of y equals sine 2t. So what's happening in the graph of y sine equal to t? So for y equals sine 2t, what do we notice here? What we notice is the following. The period, so just from graphing, the period is equal, in this case, to pi. So what's happening is that because as we realize that the graph repeats itself 2 times in the interval from 0 to 2 pi. From 0 to 2 pi, causing the period to be half this amount. All right, so multiplying 2t is actually, and the effect graphically is that the graph of sine 2t, the period is pi. So the graph of sine 2t now became like this. This is 2 pi. That's halfway through. And it's like the sine, repeat, it's the sine. I did not shrink. I didn't do anything here to the amplitude. My amplitude is still 1. But what I did is I changed my period. My period now is pi. It's like I took the graph of sine and basically compressed it a little bit. So fit 2 period into the period of that. And if this is pi, should be pi over 2. And what do you think this should be? Can anybody figure this out? If this is pi, where is going to peak? What do you think this is going to be? Use common sense. You don't have to do a lot of math. It's from here to here, pi. If those are equal, how much this should be? This should be your pi over 4, pi over 2, and this would be 3 pi over 4. Pi over 4 plus pi over 4 plus pi over 4 plus pi over 4. Okay. Now, if I take y equals sine 2t, when I took y equals sine 3t, what happened here? What happened here is that the graph repeats itself 3 times in the interval from 0 to 2 pi. In the interval from 0 to 2 pi. Okay, so the graph repeated itself 3 times. This makes the period here to be 2 pi divided by 3, because that's how many times the graph repeated itself. So now the idea is, what's the rule in general for the period? So what's the rule in general? So the main thing here is that to affect the period, you have to multiply the inside by a constant. That's really how we are affecting the period. To affect the amplitude, you have to multiply the outside by a constant. So that's caused a vertical change, and this caused the horizontal change. Okay, so now what's the formula in general? So here we are. The formula is that, or the following rule. Okay. The graph of the following function. Y equal sine bt. B is a constant, is what we're multiplying t by. Or y equal cosine bt. So now I'm multiplying t by a constant. The graph are periodic. So it means they repeat themselves. But the period here is, I want to give it a wild guess based on what we did. Who would like to give it a guess? When b was 2, It was 2 pi over 2, because then we fit 2 sine between 0 and 2 pi. When b is 3, we had 2 pi over 3, because when b equal to 3, we had 3. The graph repeats itself 3 times between 0 and 2 pi. So in general, the formula is going to be 2 pi divided by b, because the graph will repeat itself b times between 0 and 2 pi. So any function are periodic, and the period is 2 pi over b. So let us immediately practice those. Find the period of each of the following functions. Okay. All right. So y equal sine 40. Okay. What is going to be the period? So first we identify the b, and then we find the period using the formula. So what's playing the role of b in this case, and what is the period? Quickly, let us see. So what are we multiplying t by? In this scenario, my b is absolutely equal to 4. Now my period is 2 pi over 4 or pi over 2. Graphically means the following. When I sketch this function, that's what it means graphically. This is pi over 2, right here. That's like the graph of sine, but it's squeezed so that the period is pi over 2. That's really what it means. And in this case, I did not touch the outside. So my amplitude in this particular scenario have not changed at all, because I did not multiply the outside by anything. It's my period was really changing. That's the pi over 2. Now, this point here is half of pi over 2. It's halfway through, means half of pi over 2. That's really going to be a pi over 4. It's nice to know. Okay. So now I'm changing period. Now that I am changing the period. Now suppose I give you y equal sine, okay, 1/2 t. What multiplying by inside by a half, how will this affect the period? So you identify your b, and then you give me the period, and then we sketch to know what does this mean. I'm going to go back to you guys. I'm going to ask you questions. Christian Arenas. Christian, are you with me? Okay, Clarissa, are you with me? Clarissa?
Yeah,
Yes, go for it. What's the b?
the b would be 1/2.
Right. What's the period? I use the formula verbatim. 2 pi over b. Gonna give me how much? 2 pi over b. Don't be afraid of fraction. This gives me how much? How do you divide by a fraction? It's 2 pi.
Multiply by the reciprocal.
Right. So it's gonna give me how much? 4 pi. So multiplying t by a number usually less than a half is gonna stretch the period. So now how is the graph gonna look like? It's exactly like the graph of sine, but now the period is going to be 4 pi. So it's like the graph of sine. You can imagine you are stretching it horizontally to get a much larger period. So I usually divide in 4 because that's how the graph of sine is. So it peaks here, that's the top, and then it's going to bottom up, and then that's the valley, and that's 1 period. So if I want to graph it over 2 periods, so if I want to graph it over 2 periods, I'm going to repeat my graph verbatim and going all the way up here. So if I do that, this should be 8 pi. Okay, so that's over a 2 period. And the value here is how much? What's the value here? Clarissa, can you tell me, since you're with me? Exactly, it's halfway. If this is 2 pi, that's going to be 2 pi. So the period is not 2 pi anymore. The period is 4 pi. That's where we're going to affect the period. All right, I'll give you, we're going to do 2 more, and then we're going to mix everything we've learned from the previous section and this section. So now suppose I give you y equal the sine of pi t. Okay, and again, the same question. I want the period. And finally, cosine pi over 2. So always identify the b, and then once you identify the b, we can find the period. You identify the b and then the period. Okay, the first one. Giselle, are you with me? Giselle. Okay, Jacob, are you with me?
Yeah. Oh.
Okay, Giselle, go for it.
So the B is pi.
Please pi. The period.
It's 2 pi over
Don't
pi.
be afraid. Yeah, which is how much? 2 pi over pi.
Which is just
It's just 2.
2, right? Okay.
Yeah, don't be afraid. Yes, I know that is going to scare you. The period is exactly 2. So now we're creating a scenario where the p is 2. So this function will reflect, will give me a graph. It is a sine. For some reason, I'm giving you only sine, but it's the same thing. The period is 2. I'm just changing the period in those problems. Okay, the last one. So that's really my goal today, is really playing with the period a little bit. Now, the last one, who would like to give me the answers before I bug you? Okay, Jacob, because I called you. Jacob, are you with me?
Yes, I'm with you.
Okay, what's the B?
Pi over 2.
What's the period?
Period should be 4.
Okay, let's see if he's right. It's 2 pi over 2. It's 2 pi times 2 over pi. The period is 4. So we're creating a function where the period is actually equal to 4. So if I ask you to sketch the graph over 2 period, what I expect is this. A period is 4, 2 period, it means from 0 to 8. What's the graph? It's the graph of cosine. I have it multiplied by, so the amplitude is not changing. It's a 1, and that's a -1. So the graph is going to go down, up to 4. So halfway through is going to be 2. That's a period. And then it's going to go down, up, exactly the same thing. So that's really my period from here to here. And this would be, for example, a 6. So we have a good idea about that. Okay. Now, what we're going to do is, please, if I turn the page and you are not done, let me know that you are not done. Now we're going to mix and match. What we did last time was this new ideas. So now the general form is what we call the sinusoidal function. Suppose I have a function that looks like this. Okay. Y equal. So I'm going to basically take everything we did last time and we did this time. Bt plus k. Or y equal a cosine bt plus k. So I'm multiplying the outside and I'm multiplying the inside. So we're putting everything we've learned together. So this is the functions. What's the period of this new function? What's the amplitude? And what's the midline? Okay, I'm gonna do that step by step. What affects the amplitude? What affects the amplitude is multiplying the outside by a constant. That's what affects the amplitude, because this takes the graph and stretch it. So my amplitude is the absolute value of A, because because A could be positive or negative. The midline is taking the graph and shifting it up. So the midline is y equal to k. The period now changed because I multiplied the inside by a constant b. So this is going to immediately affect the period. And now the function will repeat itself every 2 pi over b. So that's going to be the general formula. And then whether A is positive, it will look like the graph of sine. Negative, it will look like the graph of minus sine, the same thing as here. So I'm going to do a very, so I would like to do 2 types of problem. The first problem is, by now, I think, question is find period, amplitude, and the midline of the following function. So, okay, based on what we did so far, this problem should not be hard anymore. So I'm going to give you the function. Suppose I take y equal minus 2 cosine pi over 4t plus 6. And the question is really to figure out everything about this function. So I'm going to figure out the period. I want to figure out the amplitude. And I need to figure out the midline. And the way we understand it, multiplying the inside by a constant, but this will affect the period. This will affect the amplitude. That's the horizontal, that's the vertical stretch, and that's the shift. So I'm getting answer. Tim is telling me the amplitude is 2. Absolutely correct. That's my A. The amplitude is 2. Very good. Tim, stay with me. What's the midline?
The midline is 6.
Why?
Y equals 6. Yeah.
Yeah, because it's a what? It's a line. So 6 doesn't really make sense. What's the period? And don't be afraid of that.
The period is 2 pi over 4, which is
That's the B.
right. Pi over 4 is B, and the period is 2 pi over B. So it's 6, I think.
Okay, do the math. Do the math. How do we divide fraction? It's 2 pi
times the reciprocal of, so 4 over pi. So you'd have 8 pi over pi, right?
Right.
So the period is 8.
The period is 8. Do it very what? Slowly.
Okay.
Okay. And it looks like the graph of sine or minus cosine.
It looks like, oh wait, am I still muted? I'm unmuted. The graph is, wait, you're asking about the stretch, or?
No, how's the graph gonna look like? Having a minus will look like will make the graph looks like, that's what I want, minus cosine.
Oh, okay.
Not cosine because I have a minus in here. All right.
So, but the amplitude, when you're figuring out the amplitude,
2.
minus doesn't matter?
No, because the amplitude is a distance. Is how far is a distance. The distance is a positive number. Okay? The amplitude is positive, but the graph would not look like cosine. It's going to look like minus 2 cosine.
Oh, okay. So it's going to start from the minimum?
Okay, let's graph it. Let's graph it. So all of us, we're going to graph this function. We know everything about it. Now we're going to be able to graph it. So let me see if I can graph it right here. So, okay, I'm going to graph this function. So I'm going to graph it. So when I graph, I look at everything. My midline is y equals to 6. I usually like to start with my midline because it orients me. I know where I am. That's my midline. My period is 2. It means my function is gonna go between, so that's the highest from here to here, that's 2 units. Okay. Now the period is 8. That's my 8. And then what else do we know? What else do we know? It looked like minus the cosine. Now the cosine, they start usually at the max. So minus cosine is gonna start below. So minus cosine, it doesn't start at the midline because the minus is gonna start like this. And that's the period. So we're gonna go back in here. So that's the graph I am really after, this piece right there. And halfway through, that's my 4. So it's gonna go up, reach its peak at 4, go back down to 8, and then start all over again to 8, and over and over and over. So this is where my peak is. This is my 8 because that's a 6 plus 2, and this is equal to 4. And that's the graph that I should expect. Please ask questions as I am moving on. Okay, so now if I have this form, I can basically understand what they are talking about, what kind of function they are talking about. Now I'm going to go backwards. Now I am going to give you the graph, and you have to give me the formula for the function. It's like what we did in the previous section. So I'll do the first one, and I let you do the other one. So now find, the question is, I will give you the graph, and this is my problem. Find a formula that will fit the graph, as simple as that. So find a formula that fit the graph. And the formula should be either a cosine bt plus k or a sine bt plus k. So I will do an easy one, and then I will let you do the harder one. I mean, we'll work on them. So suppose I have this graph. Okay. And I'm gonna do it. I'm gonna start here. I'm doing a very basic one. Okay, and this is 6 pi. And then it repeats itself. The maximum value is going to be, I'm going to keep it at 1, and the minimum value, I'm going to keep it at -1. So I'm not changing those, but I want the period in this particular problem to be 6 pi. And that's my period, 6 pi. Means my graph will repeat itself. That's going to be 12 pi. That's the picture. And the question is, find a formula. Okay, when we need to find a formula, again, we look at the picture very well. We should figure out the amplitude, the midline, and everything. But now I'm giving you an easy scenario. So the question here, the amplitude is 1. And the midline is y equals 0. And the period is 6 pi. That's the period. And the graph look like a sine graph. Okay, that's what we have. So how is the formula would look like? The formula is going to be equal, y equal, amplitude is 1. It look like a sine bt plus 0. And the question is, we need to find the b. So we need to find the b that will make the period equal to 6 pi. So when I'm giving you the graph, and you have to figure out the formula, you figure out all those things. But the main thing would be, what's the b that will give me a period of 6 pi? It's not hard to find the b. What's the relationship between the period and b? Let us see the relationship. The period is 2 pi over b. Once you memorize this, we are set. So to find the b, we're going to say, okay, we're going to set 2 pi over b equal to 6 pi. So I'm going to find the b so that the p is 6 pi, and solve for p. Sorry, solve for b. Okay. So to be able to find the b, I said, okay, they want a period of 6 pi. So I want the b so that 2 pi over b equals 6 pi, and solve for b. Now, how can I solve for b in this problem? Does it look hard? What's the b? I multiply 2 pi by 6 pi. Now I don't memorize. I don't know why. Why you want, yeah, why you want me to multiply 2? Yeah, exactly. So to solve, I say, okay, 2 pi equal, I multiply by b both sides to make it easy for us. I multiply by b both sides to get rid of my unknown. And then to get b, I need to divide by 6 pi now. Divide by 6 pi. This is going to give me b equal 2 pi over 6 pi. It means 2 over 6, which is 1/3. So I repeat, exactly. So I repeat, 2 pi over b is the period. To solve for b, multiply by b both sides, would give you, and then you want to isolate the b, divide by 6 pi, it gives you 1/3. So this will give me the formula for my y, and the y is going to become the sine of, instead of b, 1 over 3t. And that's the function. If you take your calculator and you graph it, you get exactly this graph. It means you get the graph where the period is 6 pi. So we're actually changing the period. Okay. Right now I'm going to do a little bit harder problem. And it's a worksheet. So we're going to start it. And it's on Brightspace. The worksheet is on Brightspace in case you guys cannot read very well what I have. Can I move on? All right. Okay. Here is my question now. I'm giving you a graph where the period is not 2 pi anymore. So I'm changing the period. And the question is, determine the period, amplitude, midline, and then find a formula of the form, a cosine bt or sine bt, for each of the trigonometric function below. Okay, so these are the function, and I would like to find a formula that will fit, that will represent this, what we call sinusoidal function. So how we are going to do this? We have to orient ourselves. So we have to figure out period, amplitude, midline, and etc. Okay, so let's figure this out. What's the period in this problem? What's the period? I start from here, and I start seeing how long it takes for the graph to repeat itself. So quickly, I want the answer on chat. You guys see the graph? 4 pi. The period is actually 4 pi. We start here, we go up, we go down, and then the graph is repeating itself. So that's my period. So from here to here, that's the cycle, and that's 4 pi. Okay. Then I need the midline. Midline and the amplitude. Actually, let me write them up. So midline and amplitude. And the amplitude. Okay, so let us first identify the max and the mean. So the max is 4, that's help, and the mean is -2. So my midline is, as I said, you can use the formula or you can look at it. From 4 to -2, I have a 6. So my midline is going to be, my amplitude should be halfway. So my amplitude should be equal to 3. So you either look at it or you take the max plus the mean divided by 2. So it's going to give you 4. Minus the mean divided by 2. It's 4 minus -2, which is going to give me a 6 divided by 2 is a 3. And my midline is halfway. So if this is from here to here, that's my amplitude, which is a 3. My line, that's my midline. So the midline is equal to how much? 1. Exactly. So it's the max plus the mean divided by 2. Very good. The period is 4 pi. The graph look like, so now once I have my midline, I can visualize the graph. It's starting at the midline. It means graph looks like sine. Like sine. Okay. Now I need the formula. So the formula y equal. A is my amplitude, which is 3. Sine of b times t, that's my b that I always have to worry about, plus 1, which is the midline. Now let us find b. How can I find b? Okay, b is not how to find b. Okay, to find b is as follows. We say 2 pi over b should be equal to the period. And now this means that 2 pi, I multiply by 4b to be able to isolate it. It's 4 times b. Divide by b, both will give me 2 pi over 4 pi equal to b. It means my b is a half. So my function will have the following form. So my function now, I'm going to write it here, will be 3 sine 1 over 2t plus 1. Take this function, graph it, you get exactly what we have. All right. The second one. I will give you a minute, all of you, to try to figure it out. And then I will pick one of you to give me the answer. In case you don't see it, this is a -1. And this is a 3. But it is on black, it's on bright space if you go to worksheet. So I want you to do it yourself. Okay. Anybody ready? Anybody ready? Okay, I'll ask question then. William Kishon, are you with me? Remember, guys, I don't know you, so, you know, and I forget who's talking. William, are you with me? I guess not. Okay. Anybody else? Because I definitely want to get this going before I give you the homework. Okay, midline. Anybody figured out the midline and the amplitude?
Midline is y equals 1.
Y equal to 1. Do you agree with him? What's the amplitude?
2.
2. From -1 to 3, that's a 4. The amplitude is halfway, which is a 2. So the amplitude is equal to 2. So, and the midline is right there. So that's my midline. And my amplitude is from here all the way to here. That's my 2, both sides. The period, please keep going. What's
4.
the period? 4. Absolutely correct. That's a cycle up to 4. And does it look like a sine, a cosine, a minus sign, or a minus cosine?
It's a reverse cosine.
So absolutely like a minus cosine. Okay, now to be able to find the formula, I need the B. Once I have the B, I basically have my formula because I will have every aspect of it. Because the formula will be the A cosine BT plus K. So we have to figure out almost everything from it. So what's the B? How are we gonna find the B?
I believe your B is 1/2 pi. I mean, 1 over 1/2 pi.
Okay, maybe I'm a bit slower. So how do we find the B? That's the relationship. 2 pi over B, that's
Equal to
the period.
4. Right.
Once you set up, you're done. You don't have to guess at all. 2 pi over B is the period. So that's the period. Because I don't want you to memorize all kinds of formula. That's the only one I really want you to memorize it because it's hard to figure it out by yourself. Now I need to solve for B. To solve for B, I multiply both by B to isolate it. So it's going to be 2 pi equal 4 times B. Now to solve for B, divide by B. And that will give me B equal 2 pi over 4. It means B equal pi over 2. So don't be afraid of having a pi for B. Actually, those scenarios will come up tremendously. And then now I need the formula for my function. So my y will be equal to every piece.
-2.
-2. I'm listening.
Cosine.
Cosine.
Parentheses. Pi over 2. T plus
T.
1.
There is a T in here. That will be the graph. So you take it, use your calculator or Desmos, which is a very nice program, and then graph it. You get exactly a function where the period is for. So now we're really changing our period. Now we can find a formula for a function that looks like sine of cosine with any period that you're really interested in. Okay, in the last 2 minutes, can we do the last one? And because you may not be able to see carefully, that's a -6. And then that's it too. Okay. Can you go over how do you term it's a minus cosine or a minus sine? Absolutely so. So I will back up to your classmates' question. First, you find the midline. That's why I keep telling you the midline is crucial. And what's the difference between the sine and the cosine? Can anybody help with the question? What's the difference between sine and the cosine? The sine start at the midline. The cosine start either at the top or at the bottom. It does not start at the midline at t equal to 0. That's really give us a lot of guidance. So for example, suppose I draw, so the class, your student class, one of your classmates is asking me, how do I know it's a minus sine or a minus cosine? That's really the questions that I've been asked. So suppose I have the graph like this. I'm going to start like that, go up and down. That's a sine because we start right at the midline. If I start at the midline and I go down and then up, that's again, I'm starting at the midline. That's a minus sign. So that looks like a sine, and that's the minus sign. How does the cosine work? The cosine is like that. Suppose you have the midline here. If the graph starts from the max, go down, up. this is the cosine. It doesn't start at the midline. Or if you can start from here, go up, down, this would be the minus cosine. Okay, so now ask always, can you go up a little bit? Yeah. Okay, so the sine start at the midline, either go up or the minus, but the starting point, that's really what should be, that should guide you. The cosine does not start at the end point because at t equal to 0, the cosine is 1. So it's going to start right there, not at the midline. That's what can help you a little bit. All right. Fine. I guess we are out of time, which is okay. So for Wednesday, I want you please do the homework in the book. Make sure you do the homework in the book and finish this worksheet. See how well you guys can do. And you have a quiz next time, and the quiz will cover what I did today for sure and what I did last time. I will explain on Brightspace exactly what you are responsible for the quiz. All right. Any questions? For those who have any more questions, you can stay with me. For those who don't, you guys can leave. All right. Okay. Now I'll